Hello, guys. I want to confess first. So, this was yesterday's liquidity challenge question, but since this is labeled as hard, I haven't done it. I have not still done this question. I am a bit intimidated, and I was thinking to skip this question even today as well, but I confessed with you guys now. I'm not sure how long I will take, but I cannot run away, right? I have to face it. So, let's face it. 23. Morse K sorted list. You are given an array of K linked list. Each linked list is sorted in ascending order. Merge all linked lists into one sorted linked list and return it. Okay, so we'll be given all linked lists, and I need to sort. I need to merge it. Okay, so I will merge it like 1, 1, 2, 3, 4, 4, 5, 6, right? Okay. The linked list are, yeah, and after I merge this, then the question is pretty simple. K is equal to list or length, so there will be K list, and it can be empty as well, or it can go up to 10 to the power 4 as well, and list I third length. So one list will go up to 500 values, and it can be negative, 0 or positive. Okay, and list I is sorted in ascending order, of course, and the sum will not exceed 10 to the power 4. Okay, got it. So how to do this question? What I'm thinking is I can do this question like my first thought is I can just merge two lists first, right? So if I merge 145 and 134, then it will be 1 1 3 4 4 5, and then I can merge the result with 26 and continue merging the result with another list, another list, another list until the end. Okay, so what's the time complexity for this? What is the time complexity to merge two sorted lists first? So the time complexity to merge two sorted lists each. How to sort to how to merge two sorted lists? What I can do is I can traverse both linked list first, and then okay, 1 is equal to 1, so that's fine. I'll increment both. It means that if both are equal, then I'll increment. If I'll just write if list I equals to list j, then increment both I and j, then push to result, push both values to result and increment I and j, right? So I pushed and increment I and j, but if one of them is less, right? If list j, suppose if list I is less than list j, so in this case if one of them is less, then what I should do is I should just push the smaller value to the result and increment just I only, right? I mean, yeah. increment the smaller value, increment the smaller one. So since this is smaller, so I'll push 3 and increment j. So now 4 and 4, they are all equal, so 4 4, and increment both 1 and 5. So 5 each. Now since there is no any value left, so it will be just 5. So it means that it will take O of n time, where n is the length of the larger array, of the larger list, right? So to merge to linked list, then this is the time complexity it takes, and to merge k linked list, it will take to merge k linked list, it will take O of n time only, right? or what? Because two more is this and this, so it will take suppose 3 of 3, and then oh, it will, I think it will be key of O n, because if there are 3, then it will be 3 into O of n. But if there are like 1000 list, then I have to do this traversal 1000 times. So I should also consider k value here. So I'm traversing once here, and for this one again. So if there are more lists, then I have to travel more times. So this is the value. This is one way. I need to do this until one of the listage. I think that I need to do this until both are not empty. Both are not empty, right? And if one of the list is empty, list has reached. Suppose if one of the list has reached to the end, then there's no need to compare. I can just add. Just add what is present, right? So this is how I can merge two linked lists. And so what is the space complexity for this solution? Since I'm creating a new result array, right here, so this is one linked list 1, this is linked list 2, and I'm creating a new linked list here. So it means that it will take O of n space, or no, I mean O of n space, O of k n space actually, because if n is the length of largest list, then it will be multiplied. So the resulting list would have the size equal to k times n, and where n is the length of the largest list, and k is the number of lists. K is the total number of lists, right? So this is complexity. I can do like this. I was thinking, can I not store this? Can I just change one of the linked list? Can I do this without creating? Can I do this without creating a new list, but by just modifying the existing list? So suppose if this is 145, can I just modify 145 here? Let's see. So if I'm given two linked lists, then I mean, if I could modify just one linked list, then the space complexity would be O of 1, right? So let's see if that is possible or not. 145 and 134. So if I'm given 1, then since they are both equal, so I need to push here. So first of all, it is 145, so I need to push 1 here, right? So it will become 1145. Oh, nice. And then it will reach here. Now 3 is here, right? So here also it has reached to this. So it means that this is the current value here. So since 3 is the next value, so I should push 3 here, and current will be here. And 4 and 4, they are both same, so that's fine. 4 and 4. So suppose in this case, suppose if there was 3.5, suppose, then in this case it would have been, this is the pointer, and it would have been 3.5 here. I would have to point 3. No, and 3.5 would be in next. So suppose 4 is after here, then Okay, now 4 and 4, they are both equal, so I would push 4. Since this is also the smallest value, so I would increment. I mean, right? I mean, if because this is the resulting, because this is the original array and I'm modifying this, sorry, because this is the original linked list, so and I'm modifying this linked list. So what I should do is, if original linked list, so there should be, I think there should be two pointers for the original linked list. One is for just traversal and another is for pointing to the current array where I should add it. So if original, so there will be three pointers, right? One is current pointer and I and j, or you can say head I and head j. So first of all, there will be current and head I, head j. So if original linked list, and this is the original linked list, so this is the original linked list. So if original linked lists value linked lists here i's value, if I say that if it is the, if it is equal or less, if it is less, if it is the minimum value, then I would just um, then just go to, then just say that current is equal to current dot next now. So in this case, since this is 4 is the minimum value, so I'll just increase the current, right? Current will go to 4. But if it is not the minimum value, otherwise I would, otherwise if I need to insert, otherwise I need to, or I can say otherwise insert the minimum value to the otherwise insert by saying that current dot next would be equal to the minimum value. Yeah, by creating a new node with minimum value and assigning current dot next equal to minimum, right? So that's what that's how we could just change the original linked list. So let me do it from the beginning. Here the minimum value is 1 and 1, the minimum value is 1, so and the current, so this would be, so current would be the head, and so this is my current. So since the original value is minimum and there is 1, so I'll just shift. First of all, I should also before doing this, then just write. So if another linked list that value is the minimum value, then I should insert. So yeah, this is the thing that I should do. So if another linked list its value is the minimum value, then I should insert minimum value by creating minimum value and assigning an update current. So in this case, 1 and 1, right? So this is my another linked list and this is the original linked list. So since this value is equal to minimum, so I should push it and push to and then update current value. Now current is this one, and since original linked list value is also the minimum value, this is also the minimum value, so I can just shift the array, then just do current. I do not need to insert anything, and this will be updated. 4 and 3, Yeah, actually, and 4 and 3, since 3 this is the minimum value, right, so I need to insert here, since this will be the current value right now. So uh I would insert 3 here and update current to 3. Now this will be incremented, and I would be increased again, I mean 4 and 3.5. So since this is still small, so this would be 3.5. Current would be updated, 4 would still be here, and it's incremented. Since 4 and 4 they are equal, so I need to add 4 first, and update it, and then update 4, and then since this is also the minimum value, so current will be equal to 4 now. Yes, and this will also be updated to 5. What I am confused right now is, should I make the pointer current and I different, or should it be similar? Because how will I have i's value, because I'm modifying the same array here. I'm making it too complex. I'll just turn on the light and come back. I mean, um, I need this pointer as well, right? I'll need the current pointer as well. So, do I need this I if I have the current pointer? I think, yeah, I do not need, right? Because the next value will always be equal to current dot next, isn't it? The value that the I is pointing to will always be equal to current dot next, right? Okay. What I'm trying to say is, even I think so, because in the beginning also, if it is 1, 4 and 5, then first of all current will be equal to 1, and current will be equal to 1. J, this pointer will be 1, so 1 and 1 they are both equal, so it will be pointing to 1 now. I mean, yeah, so first of all I would need to insert 1 here. First of all I need to insert here, because since 1 and 1 they are both equal and they are both minimum, so first of all current will be in, I think, in the beginning, or what? No, current will be here only. So I need to insert 1, that means I inserted 1 here, and now current will be at 1. And okay, so suppose if this was 2, then what would I have done? So in the beginning there is 1, 4, 5, and if it is just, then I would have 4 with the minimum, so I would just insert 2 here. Oh no, I mean, I'd not do anything, right? Current will just be here only. So it means that if it is a minimum value, then I'll not do anything. Current will be in here only. But if it is greater, so in this case, since 2 is greater, so I would insert 2 here and update the current value to this position, isn't it? So since I have inserted and updated here, it means that suppose this is also equal to 3, then okay, so now this 3 and 3, they are both equal, right? Means that there is 3 here. Since 3 and 3 both are equal, so I need to insert 3 here. I need to insert 3 here, and the value should go to, oh my god, what am I doing? Like, suppose if it was 4, then I would have inserted 3 here, and the current would go to 4, right? I mean, yeah. And update current. But since there is 3 here, so current would be equal to current dot next. It would go to another 3 here. This is 135, 145. Then I'm just messing my head here, right here. I think that I'm just making everything super complex, so the current should always point to a value where so this current value should always point to a value where I can current should always point to a value where point to a node. It means that in the beginning current should point in the beginning here. Yeah, that's why I messed up. So current should be in the beginning first, where the next value is the where the next value is the one that is being checked upon. So to make it clear, first of all, suppose if it is 1 3 4 5 and 2 3 4 5, then also it would be 1 3 4 5, right? So first of all current would be here only, and since this is equal to I1, so since this is equal is the minimum value, so I just do current is equal to current dot next, because now I need to check 3, right? So now I'll check 3 and 2 now. So since 2 is the minimum value, so I would add 2 here and then update to current here according to this algorithm, and now I look at 3. So 3 and 3 both are equals, both are minimum value, so I would first of all add 3 here and then update to current like this, and then I would increment the current value like this. So this is the next value that we are looking at now, 4, and here is the 3.5. So 3.5 is less than 4, so I would add 3.5 now, right? And the current would also be updated, and now I'm looking at 4 4. So first of all I would insert 4, and then I just according to this I just update current now because 4 is already here, and at last there is nothing left here, and since one of them is empty, So um I just continue. I mean, but what if I will also update this first. So do this until both are empty. So this algorithm was according to the case where we are not modifying the one array, we are just adding all the values to a new linked list. So according to this one, I would do until both are not empty, until both reached null, right? So in this case, suppose um, so we would go until both null has not been found. So if one of the has reached to the end, then no need to compare, just add what is still left. That's fine. Okay, I'll not change this algorithm. I'll just because this is just a logic, so I'll code according to this logic. And what if we have reached the null in the year first before this one? In that case, what should we do? Can that not happen? Like, what if they just what if there's just one and then another one is 3 5 6 10. Then first of all we are looking at 1 and the current is here, right? So since 1 and 3 we are looking at 1 is small, so current will be now here, and j, and it will already reach the next value, it will already reach the null. So since this is null and 3, so I just add 3. Okay, so it will be like 3. Okay, so it means that if one of them is null, then I don't need to compare. Okay, now I will increment 5. So since these are both null, this is null, so I will just add 5 here, and since this is null, so I will just add 6 here. Okay, so algorithm H. If another linked list its value is the minimum value, then insert the minimum value by creating with minimum value and assign an object current. And I should also change, increment the pointer in the another linked list as well, because we have found the minimum there. Okay, and yeah, so original linked list head value will always be equal to, like, current should always point. This is also the thing here. So I think this will work. So I'm doing this until both have reached null, and this is the value. So if I'm comparing, if one of them as is null, so if it is equal, then I think I've already done this, right? If both are equal, then push value to the result increment. I think this is not necessary here. Okay, so let me code. So first of all, I will just write a function. Function merge to linked list, merged two lists. List 1 and list 2, or I can say, yeah, this is original list, and this will be another list 2, right? So this is the list that I need to modify. And what I should do is, first of all, I'm looking at current, right? So this is my current and this is my mm, yeah. When I what I'm thinking is when I'm returning, I should return the head, right? Because the current will go until the null, so I should return the head. That is why what I'm thinking is I can just say that head is equal to new list node and value comma next, or I can say then dummy and dummy dot value is equal to null. So what I'm trying to say is first of all null is pointing, so this is my dummy value. So what I'll return is I'll return uh, so this is my first pointer here, and dummy dot next will be equal to original list. Okay, so this is my dummy, and while returning at last I need to return dummy dot next because this will be my head. Okay, so this is my dummy, and I should also update the current value, I think, right? So dummy dot next is equal to original list, and if the linked list is modified in such a way, like if it is modified like this, then this will be my head. So dummy's next will be the head of the result always of the modified array, modified list, right? I mean in this case also, if there is 0 here, then first of all this is the linked list. So in this case also what I do is I would always, so since 0 is less, so I would always put 0 here. Okay, so DOM is next will be what I'm returning, and I should also maintain the current value. So current will be equal to dummy. Okay, so current equal to dummy or what? I mean if current is equal to dummy and if current is changing, then so if I change current dot next, then I mean can I just say that, so this is, if this is current value, then if I say that okay, current's next is equal to 0, and then if I update current again, then that is fine, right? Then dummy will remain as it is, let's say. So I'll just say that let current is equal to dummy here, and it would be like a constant because since I'm not changing dummy again. So what I'm doing is while current or list2, I can just say that this is list to head, right? List to current, or I can say that this is original list head, or what, I don't know what to say. Okay, let this be dates only. Current is equal to dummy and list2. Okay, I will say that this is list2 head, and so while one of them is present, right, or while one of them is there, I'll continue doing this, and yeah, I'll continue doing this. So I think I don't even need to assign value and anything. So while current or link list to head, then what I need to do is I need to first of all find current dot value and this two dot head dot value, right? So constant minimum is equal to, so what is the minimum? Math dot minimum. So okay, I find, if after I find one, actually what I should do is, if only if both are present, then I should do this, right? If one of them is null, then I cannot do this, isn't it? I mean, if current is not present, suppose, or what should I do? Actually current is equal to Tommy, and because current is a value that always points to this value, right? So that always points to its next value. So what I should do here is, while current dot next actually, and this should be head dot next and current. So actually the current value will be equal to head dot next dot head dot next. So the current is equal to head dot next, right? According to this one, current should always point to a node where the next value is the one that is being checked upon. So this is the value that is being checked upon. This value is being checked upon. This value is being compared. So yeah, I should continue until there is a value here. So since current, so this is a value, and if both are present, then I will decide if minimum. Otherwise, if current is not present, then if one of them is not present, because that might also be the case. If both of them are present, then this is the case, right? If I'll find a minimum value and then do this. So if another is linked list it, and then I will check if this is the minimum value. So if this is the minimum value, then I need to do things like insert minimum value, right? And then update current. Otherwise I do a different thing. If this is a minimum value, or if current value is minimum value, then what I do is I would simply say that head is equal to head dot next. So if this is the value that is minimum, then I would just simply increment, right? That is what I'm doing here. Then if original head value is the minimum value, then just do current is equal to current dot next, right? So I'm just doing head is equal to head dot next because this is the pointer. Yeah, I will do this later. And if both are present, then I will do this. But if otherwise, if both are present, then I will do this. Otherwise, I mean, if both are present, then I will do this. Otherwise, if both are not present but only this is null, I'll just write null to make it more simple. So if both are present but if current is null, or if this is null, if both are present then this is fine, right? But if one of them is null, if current is equal to null, then I mean if both is present then I'll do this. Otherwise, if one of them is null, this is null, then if current is equal to null, then I'll just add like I did here, right? So if one of them is raised to, then no, just add what is left. So if current is equal to null, then it means it is like, so current is here, right? So I need to add insert minimum value and update it. So if there is 2, then I need to insert 2 and then update 8 here. Update that 8 is the next. So if otherwise, if list 2 is null, then I'll just need to, yeah, if list 2 is null, then what should I do? If there is nothing written, then I think that I can just return, isn't it? Then I just can break if list 2 8 is null, right? Because if there's nothing in list 2, then I can just return as it is. So it means that all I should do this only until I find it, or I can say list 2 8 actually, while this is present. Because suppose if this is the case, suppose this is the original list and this is the modified list, then it is also here, then domain value is also here. So since this is null already, so I do not need to do anything, isn't it? I can just return 1 immediately. Yeah. While list to head, so I should also change this. So while list to head, so if it means, what should I change here? So I don't even need to check this. If both are present, it means that list to head is always present. So it means that if current is present, then I will do this. Otherwise I'll do this. If current is not present, I mean if there are other value, but if it is already it is to null, then I'll just keep on inserting only, right? Then I'll just keep on inserting if current is present. Otherwise I'll just minimum value and then update head. Actually, what I can do is I can check if current is present only for this one. If current is present and current value is less than mean, then I can do this. Otherwise I don't even need to check if current is present or not. So I will always do this because list to 8 is always present, so I will always insert minimum value. If this is equal to minimum, then I will always insert a minimum value and do this. And if current is present and if the value is equal to minimum, then I will update it. Okay, I think this is the concise code, better code. So yeah, if current is present and current value is equal to minimum, then I will update it the next. Otherwise Yeah, I need to write code for this one now. um, Insert minimum value and update it, right? So I can just call a function, maybe insert min, insert uh, insert insert node to next value, right? So I need to insert node to next value of here, isn't it? So if this is here, then suppose if there is a 0 in between, then I need to insert 0 on the name heads next, right? So that's what I'm trying to say by doing this. Insert node to next head, and then I need to update. After I insert it, then I need to update head is equal to head dot next. So after I update, yeah, after I insert 0 here, then head will be equal to head dot next. So insert node next. So let me write this code. So function insert node to next, and if this is a node value, so here it means that if I'm given a node value, there might be another node, so I need to insert new node here in between node and another node, right? So how to do that? So first of all, I think so I should change it like this. So first of all, what I should do is, I think that I should first of all node dot next. So I should store next is equal to node dot next, right? So that node dot next is preserved, and then I should add node dot next to, oh, I should also pass min value here. So this is the new node value, and node dot next will be equal to new list node value will be equal to new node value, right? So this will be my new node. So once I do this, then it will be like nodes new node will point, and this will point to next, isn't it? So node dot next should be equal to node whose value is equal to new node value and whose next points to this next. Okay, I think this is it. So now once this is finished, now the nodes next will be equal to new node, and new nodes next will point to this node. This is the next node. Yeah, so nodes next will is pointing to a new node, and new nodes next is pointing to this next, right? Value next. I think yeah, this is it. So this will insert this value. So nodes next is equal to this one, and yeah, let me check if this works or not. So let's just pass console.log merge to lists 0 and lists 1. Line number 107. Oh my god, I've already spent 45 minutes for this question. Bad alloc. So I'm just trying the console list 0 and list 1, right? So in list 1 would be 145 and 134. So original list would be 145 and this would be 134. Current. What's wrong? Merge two linked lists. DOM is equal to new list node. Make me console.log original list and list to it. So okay, it is 145 and 134. That's okay. And DOMI. So let's 1445 and 134, right? So first of all, it will be pointing, it will be here. So Tommy.next will be equal to original list. So Tommy.next will be this one, and it will also be here, while this to it will be here. So first of all, here is equal to Tommy, and while this to it is there, so current is equal to 8.next. So current will equal to 1, and we are doing 1 dot value and 1 dot value. So minimum will be equal to here 1, and what I'm doing here is if list2 dot value is equal to minimum. So since 1 is a minimum, so we are trying to insert node to next 8 comma min, right? So we are trying to insert here heads next will be equal to 1. So and update 8 is equal to 8 dot next, right? I'm just trying to do that on here. And if current is equal to, if there is current and current value is equal to min, so current value is equal to 8 dot next. Oh, what is happening here? So head will update to here, and will current, what will current value change or not then? Yeah, since heads next is changing, right? So I think current, what I can just do here is current value, current value. But what if 8 dot next is not there? It is a bit tricky. Oh my god. Yeah, but what if there is 8 dot, there is no 8 dot next? What if 8 dot next is null? If 8 dot next, if there is 8 dot next, then I will change it. Otherwise, current that value will be equal to math.max or max value. So value can go up to 10 to the power 4. Okay, math dot Okay, so only if there is a the next present, then this will be current value is equal to a the next value. Otherwise, the minimum value will always be equal to this value. So this will never be equal to the minimum value, because this will be the minimum value always. If a dot next is present, yeah, okay. If a dot next is present, then current value is updated. It is equal to a dot next. It is equal to a dot next. Why is it drawing bad luck? I don't know. A function insert node and new node value, right? New list node, new node value comma next, because this is the next value of the node, and I'm trying to change the next value of the node. Is this not making sense? Let me check. Console.log minimum. Oh, 11111. Okay, so the minimum value is 1 in the beginning and 8 is here. So I would need to insert, right? I need to insert 1 here, and I also updated 8 here. And since this is also equal to minimum, so I'll also update it here. Oh, okay, I see. I also need to update this as well, so that's what I did not do. If it is equal, then I missed this part. If another it is the minimum, then insert and increment the pointer in another linked list as well. So that's what I missed here. Head is equal to header next, and these two heads should also be updated. So header next. Okay. So std out is 113445. So yeah, 113445. Yeah, I think this is fine. So let's, yeah, this is what I was missing. So I should not have done that. I should not have missed that. So first of all, what I'll do now is for let const list of lists, or what I can do is let I is equal to 0, I is less than lists dot length I plus plus. I should do merge to linked lists I comma lists I plus 1, right? But what if there is just one linked list? Because k can be 0 as well. So if k is 0, then I should return empty. And at last I should return lists 0. But if there is no list, if list dot length, if it is 0, then I should just return empty. But if there is just one linked list, then it would be, and if list dot length, if it is equal to 1, then I think that what I could do is I could just start from 1 and then I do 1 1 minus 1 and then I, right? So there is just 1 2 3, then it would go until this value. So first of all 2 and 1 would be merged to 1, then 3 would be merged to, this is just list 0. So first of all it will begin with the second list, so this will be merged to 1, and then third would be merged to 1. Yeah, and at last return list 0. So if there is just 1, if k is just equal to 1, then it would just return this. Okay. Oh, it would return next. What I'm thinking is, first of all, I mean, in this case, so first of all 145 will be changed, right? 145 will be changed to 113445. Let me just console that log here. Do I need to return? Oh, I need to return. Okay. I return, then yeah, I can just return this 0. So first of all, I'll just console logging here. So first of all, it will be 113445, right? And yeah, I can also console the log what comes in here. So first of all, it should be 145 and 134 for this one. It should be 145 and 134, right? 145 and 134, and then it should be 113445, yeah, and then 11345 and 26. But why is it, when I'm doing passing this to, then why is it, I mean, exceeding time in this case? So if it is 113446 and 26, then something's wrong. So first of all, dummy 8 will be here, and then this would be list 2 8, and right, and if 8 dot next, then current value. So current value will be equal to 1 here. Current value will be equal to 1, and the minimum will be 1 into 1, right? So since if the value is not equal to mean, so it will not do anything, and since this is equal to mean, so it will be updated to, so it will be updated to 8 dot next. So this is where it will be updated. And now next 3 and 2, so 2 is the minimum value, so since 2 is the minimum value, so 2 will be inserted here, and it will be updated, and list 2 8 will also be updated, right? Here it will be inserted and it will be updated, list 2 8 will also be updated. And since 2 is the, since 3, so 3 and 6 now, since 3 is the minimum, so it will just be updated here, and now 4 and 6, since 4 is the minimum, so it will be updated, and another one time also 4 is the minimum, so it will be updated. So 5 is the minimum, so it will be updated, and the next value will be null here, right? So current value will be equal to math at positive infinity, and minimum will now be equal to 6 because this is the value. And since the value is equal to minimum here, so now since this is null, so now 6 will be inserted in the inside here. So 5's now node next will be null, and yeah, so 6 will be inserted here, and then 8 will be updated again. 8 was here, right? So 8 will be updated to 6, and 8 will be updated to 6, and this to no, it will also be updated to null, and this will be null now, right? So since this will be null now, it will be out of the loop. Now this will return Tommy dot next. Tommy dot next will be 1. So that's how this list will be updated, isn't it? So what's wrong then? Oh, is it math dot positive infinity or number dot positive infinity? Number dot positive infinity, okay. So first of all, 1 4 5 and 1 3 4 1 2 3 4 4 5 6. Okay, this is nice. 1 2 3 4 4 5 6. This is the answer, right? 1 1 oh 1 1 2 3 4 4. So first of all, it was 1 3 4 4 5. What? I can see that while I'm console logging this one. Now this is 1 1 3 4 4 5. But when I'm inserting here, then it is just returning 1 3 4 4 5. So where is 1 gone? Okay, it means that merge to list 0 comma list I. So list 0 is somehow not starting from this value. Okay, it means that I should keep on list 0 will be equal to this value. Okay, you mean for this input, if list dot length, if it is 0, then I'm returning empty. Oh, I should return null. Because I cannot return empty, right? I think this will not run because I'm doing too many consoles here. Console. Okay, it is running. So my major mistake was I did JavaScript error here, math.positive infinity. It is number.positive infinity. And another of my major mistake is I did not update list 0. So yeah, that was my major mistake because whenever I merge list 0 and list I, then what happened is when I inserted 1 4 145 and 134, right? So first of all, this was the case, and because this is the head, isn't it? Because this is the head of the list 0, but I inserted 1 right before. I inserted 1 right before 1, so I inserted this one before 1. So list 0 is still returning this head 1, so that is why I modified this head by returning the actual head here. Okay, that's it. Thank you guys for watching till now.